Hello students, today we'll solve one question which is based on the series and parallel combination of our capacitors. The question goes like, a network of 10 microfarad capacitor is connected to a 500 volt supply as shown in the figure. Determine the equivalent capacitance on the network and the charge on each capacitor. Note the charge on each capacitor is the charge on the plate with higher potential equal and opposite to the charge on the plate with the lower potential. So, understanding what the question aim is, we are given 4 capacitors C1, C2, C3 and C4. Okay, this is C3 and this is C4. These 4 capacitors are placed, and from here, from A to D, we have applied voltage applied to A and D terminus. Okay, the higher voltage plate, like the parallel plate capacitors. These are parallel plate capacitors because two plates are kept in the opposite direction. One is this, one is this one. So this one is having higher potential, like we will check, this is having higher potential, V equals to higher, and this one is having a lower potential. Both will have same amount of charge. The higher potential plate and lower potential plate both will have same charge on it. Okay, now we will try to understand from this diagram, from this particular diagram, what exactly the question is. First thing in the question we aim to find is the equivalent capacitance. For the parallel capacitance, the capacitor which are in parallel, arranged in parallel configuration, the equivalent capacitance CEQ is given as C1 plus C2, and in case of series capacitance, C equivalent is given as 1 upon C equivalent by 1 upon C1 plus 1 upon C2. These are the important formulas. Okay. Now see, here we are having a junction, and here we are having a junction. So this particular capacitance is out of this particular network. This is one left behind. Now see, this C1 is directly connected with C2, is directly connected with C3. So this diagram can be redrawn as C1, C2 and C3. And then this is junction A, this is junction D, and in between this junction we are having C4, C3 and this is C4. Okay. So from here we see that C1, I'll write on the top head, C1, C2 and C3 are connected serially. So to find their equivalent capacitance, this formula will be used. this formula will be used for C1, C2, C3, and then whatever equivalent will come from here, C1 equivalent, that C1 equivalent will be, and this C4 are connected as parallel, connected parallelly with each other, See, if we are finding the equivalent of these three, we will get it as a single capacitor, and that will be in parallel with C4, and here will be our voltages. A and D nodes are here, and in this range 500 volt is applied. Okay, hope you understood the diagram. You have resolved the diagram according to our understanding. Now we will go to the solution. Given capacitor is C1, C2, C3 and C4 connected as shown in the figure. C1 is equal to C2, C2 equals to C3 and C4 is equal to C3. So all the four capacitors are equal, 4 equal capacitors. Their numeral value is given as 10 microfarad. This 10 microfarad can be written as 10 into 10 to the power minus 6 farad. And the connected, these all C1, C2, C3, C4 are connected to a voltage supply of 500 volt. Voltage supply of 500 volt. Now in this given network, C1, C2, C3 are connected in series. The effective capacitance of these three capacitors will be given as Cs equals to C1 plus C2 plus C3. We will apply the values over here, and we will find that for these serially arranged capacitors, equivalent capacitance comes around 10 by 3 microfarad. Now we see that Cs, the equivalent capacitance, and C4 are connected in parallel to each other. The effective capacitance Cp will be given as Cp equals to Cs plus C4. So Cs is 10 by 3 from the above equation and C4 is given as 10. So the C4 is 40 by 3 microfarad. That is the effective capacitance for the whole network. This whole network is resolved and equivalent capacitance equals to 40 upon 3 microfarad. If you want to solve it further in the decimal value, we can do it like this: 39, that is 1.3. So C equivalent will come 13.3333 microfarad, and taking the round off, it will be 13.34 microfarad as our equivalent capacitance of the given network. Now in the B option, what they have asked us was charge on each capacitor. Charge on each capacitor. So here one thing which we need to understand is, when we are dealing with the capacitance in the charge, C equals to QV is a formula. C equals to QV is a very important formula. Here we have three different components, C, Q and V. C, Q and V. So when we think that C is constant, and we do not want to vary C from this thing to that, like this number to that number, in that case our charge and potential will be varied. Now when we see a series combination, in this case the charge on every capacitor will be same, Q, 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 Q. But if Q is also same, one needs to be varied to maintain these at constant level. When charge is also same, V will be varied. So in series, charge is same for all capacitor, V varies. and vice versa is for the parallel combination. For parallel combination, Q varies and V remains same. Okay. So see, C1, C2, C3 series combination will have same charge but different voltages across it, and C4 is in parallel combination will have charge different but voltage same as CS, voltage same as the equivalent capacitance coming from C1, C2 and C3. In case of C1, C2 and C3, potential difference across AB will be Q upon C1, BC will be Q upon C3 and CD will be Q upon C3. Basically this is the potential difference across capacitor 1, this one across capacitor 2 and this one across capacitor 3. From this particular formula we have derived V equals to Q upon C, that is what we have taken, Q upon C1, C2 and C3. Okay. Now to find the total voltage, we are summing it up as we did summation for the series capacitance. So Q upon C1 plus Q upon C2 plus Q upon C3 is in parallel with Q2 upon C4. So the total charge, this is equals to V total. This total charge will be 500, sorry, this total voltage will be 500 volt. Okay. Now Q is a common, we will remove it and we will get 1 upon C1 plus 1 upon C2 plus 1 upon C3. The value of 1 upon C1 plus C2 plus C3 we know from the equivalent capacitance we have found previously. So that is 3 upon 10. Q into 3 upon 10 equals to 100. Now cross multiplying to get the value of charge, and hence we get the value of charge as Q equals to 1.7 into 10 to the power minus 3 C. C is coulombs here. So this is charge stored by C1, C2 and C3 which are serially arranged. Now capacitor 4, for the capacitor 4 what we have is charge is different, so Q dash upon C4 equals to 500, voltage will be same, voltage 4 CS and C4 equal, that is equal to 500 V. Cross multiplying again to get charge on C4, 500 into 10 microfarad converted into farad, and hence we get charge on capacitor 4. Q dash gives charge on capacitor 4 which is arranged parallel to CS. So that is the question done. We have found the equivalent capacitance and the charges on serially arranged combination of capacitor and parallelly arranged combination of capacitor. Over here the single point which you aim to remember always and always make a note of it. In series combination charge is same. See, S and Q are nearby, right? S and Q are nearby, so they will be same. And in case of parallel combination, Q will be different. Q will be different and V will be same. So From here we cannot justify it, but from here we can remember S and Q. S, Q will have the same instead of P, Q, because P and Q are neighbors. They are not good friends. They are neighbors though, but they are not having better understanding. Hence in case of parallel, Q is different, whereas S and Q are having very good friendship. Because of that, in series Q is same. Series, S for series, and then Q is same, S for same. Okay, you can remember it in this way. This information will be of great help whenever you will try to solve such kind of questions. So that's all for today's class. We'll meet up in next class with a new topic or a new question. Till the time, have a good day. Bye bye.